Now let us discuss question number 1 and 2 of your exercise 8.4. So question 1 is express the T ratios sin A, secant A and tangent A in terms of cot A. So I have to write sin, secant and tangent in terms of cot. So to start with your answer, again you need to give a second thought that we are there in the application part of somewhere sin square theta plus cos square theta is equal to 1, secant square theta minus tangent square theta is equal to 1 and cosec square theta minus cot square theta is equal to 1. So these are the three key ideas I do have to apply to get the answer of all the questions given in your exercise 8.4. As I shared question number 3 and 4 two parts already with you in previous. So here I have to decide when I have to express sin in terms of cot, which of these three I can pick. So you see, now to express sin in terms of cot, you see here it is cosec square theta minus cot square theta is equal to 1 because I prefer wherever the cot is there and with it cosec is there and I am known to the T ratio sin is the reciprocal of cosec. So very comfortably I can express cosec in terms of cot from this identity and whatever the result will be there I will take the reciprocal of that and cosec automatically will get converted in terms of sin. So sin I will be able to express in terms of cot. So let us see how. If I will pick this, so that's why please think it over. Do not start answering immediately. You need to give a second thought out of these which I should prefer first and why that is very important. So why did I pick up this? Because sin I need in terms of cot and this is directly there cosec and cot and cosec is the reciprocal of sin. So this will solve my purpose comfortably. So here it is cosec square theta minus cot square theta is equal to 1. Cosec I have expressed in terms of cot. So as cosec is the reciprocal of sin, so take reciprocal of both the sides. So 1 upon cosec square will make it sin square and here it will become 1 upon 1 plus cot square. So then 1 upon cosec square will become sin square and this is equal to 1 upon 1 plus cot square. To solve the square from this side you need to take the square root that was taught to you in class 9 especially or in class 8 in the topic of square root. That was the purpose to teach you squares and square roots. So that is the application or we are using that square root as an utility here in class 10. So need to take the square root of both the sides and sin square will become sin and square root of this side 1 itself is a perfect square so it will remain 1 and denominator will be there in terms of square root. That is 1 plus cot square theta. In that way, I have expressed sin in terms of cot and here you can leave. No need to go for any kind of rationalization and all. Second is secant in terms of cotangent. Now again you see here, secant and tangent are there, this identity is there and I know that tangent is the reciprocal of cot. So if I use this to express secant in terms of cot, I can write secant square theta minus tangent square theta is equal to 1. So then secant square theta will be equal to what? 1 plus tangent square theta. And tangent you express in terms of cot, what does it become? Secant square theta is equal to 1 plus 1 upon cot square theta. So if you will take the LCM there, the secant square theta will become cot square theta plus 1 whole upon cot square theta. So then you need to take the square root of both the sides again. So here it will be, again you see the denominator there is a perfect square cot square theta. So square root of that you can express as cot theta and your numerator again will remain as third form cot square theta plus 1 whole under the root. So now secant also I have expressed in terms of cot by using which identity? That is secant square theta minus tangent square theta is equal to 1. Then to express tangent in terms of cot should not be an issue for anybody. All of you know that tangent is the reciprocal of cotangent. So directly you can express it. Tangent theta is equal to 1 upon cot theta. So these three parts. One sin in terms of cot, then secant in terms terms of cot and tangent in terms of cot. So I have expressed sine, secant and tangent in terms of cot by using the preferable identities as per my knowledge to get the answer of all these three. Then your second question is, write all the ratios of angle A in terms of secant A. Now there are 60 ratios. Out of 6, I have to convert other 5 in terms of the 6th, and 6th given to me is the secant. So now all other I need to write in terms of secant. So let us begin with secant square A minus tangent square A. So I can express comfortably tangent in terms of secant. So what will be tangent square A is equal to, if you will take tangent square to that side to make it positive, so it will become this side and then it will become secant square A minus 1. So tangent square A is equal to secant square A minus 1. Then tangent is equal to what? Secant square A minus 1 whole under the root. So tangent now I have expressed in terms of secant. As I know that cos is the reciprocal of secant, should again not be an issue. Directly cos can be expressed as 1 upon secant. So tangent is over, cos is over, and to express sine in terms of secant now, I can use sine square theta plus cos square theta is equal to 1. Why? Because I know if I express sine in terms of cos, cos again is the reciprocal of what? Sec. So I can express cos in terms of secant square here. So sine square A will be equal to 1 minus 1 upon secant square A. Take the LCM, do the calculations as I did in previous part. Somewhere you will be reaching sine A is equal to secant square A minus 1 whole upon secant square A whole under the root. And when we take the square root of this side, again you will be finding secant square A somewhere is a perfect square. So that will remain secant A and numerator will be there in the third form. So now tangent is over, cos is over, sine is over. What is left? The two parts are left now. One is your cosec and one is your cot. So when tangent is over, easily I can go for cot. Tangent I have already expressed in terms of secant. And already I have expressed sine in terms of secant now. You know the left two are the reciprocals. So cosec is left. Tangent cos sine is over. Cosec I can take the reciprocal of sine. I can take the reciprocal of sine. And to express cot in terms of secant, I can take the reciprocal of tangent. So to express cot A in terms of secant A, cot A is equal to 1 upon tangent A. So cot A from 1, if you will take, this is the number 1 result we have proved. Directly you can put the value of tangent and cot automatically will be getting converted in terms of secant. Similarly, finally, if I say to express cosecant in terms of cotangent, what I can write is cosec is the reciprocal of sine, and sine already you have expressed. So simply you need to take the reciprocal of sine to express cosec in terms of secant. So please pay attention. Try to write the things as per your convenience. As I started with tangent, then cos, then sine, and after that it is very easy for me to express the another two, that is cotangent, because once I have expressed tangent, I need not to spend any more time in any kind of calculation. Simply I have to take the reciprocal of tangent to express cotangent in terms of secant. That I did there. And then cosecant is left. I know that cosecant is the reciprocal of sine. So simply you need to take the reciprocal of sine to express cosec in terms of secant. If sine was secant square A minus 1 whole under the root upon secant A, so cosec will be secant A upon secant square A minus 1 whole under the root. So then your all other parts means except secant A, all the other 5 t ratios I have expressed in terms of secant A. So please give a second thought. I would like to request you, give a second thought and do it not once only but twice or thrice. You automatically will become to understand how to proceed. Simply it needs 1 or 2 practices. So that's all for today. 2 questions, I think from the length point of view as well from the understanding point of view are sufficient. Thank you. Have a nice time.